Dear student, this is the second video on the series of Amphibian Experimental Physiology. In this video, we will learn about the effect of temperature on simple muscle twitch curve. Learning objectives. uh, at the end of this session, you will be able to explain effects of temperature on simple muscle twitch or SMT. You will be able to describe the physiological basis of these effects. You will be able to identify the instruments used in the experiment and elucidate the experimental setup and steps of it. And this is the simple muscle twitch curve that we have explained in our uh, first video. So in this simple muscle twitch curve, we had the three phases: latent phase, contraction phase, relaxation phase. And by the time tracing curve, we have measured the duration of all these phases, and we have also seen the amplitude or the force of contraction. Now we want to see what happens if I increase the temperature of the experimental setup. So what is the effect of temperature on this muscle contraction or muscle twitch? Okay, so what will happen to the duration and the height of contraction? So this is the curve after giving warm Ringer solutions to the nerve muscle preparation. So we can see the effect of temperature on the contraction, on the simple muscle twitch. And that is, we have given 38 degrees centigrade temperature warm Ringer solution, and we also wanted to see the effect of low temperature, that is 12 degrees centigrade cold Ringer solution. If it is applied on the muscle, what will be the effect on its on the skeletal muscle contraction? So what is the effect we can see here? We can see two types of effect. One effect in the duration. Okay, so what about the duration of latent phase, contraction phase and relaxation phase if we increase temperature or decrease temperature? And what is the effect of it on the height or force of contraction? It is obvious that when we are increasing the temperature, the height of contraction, you can see it is much more increased than the initial SMT. And if we measure the duration of the phases, we can see that the duration of all phases will be shortened in case of high temperature. Okay, so if we increase the temperature, there will be two changes. One, the force or height of contraction will be increased, and secondly, the duration of all these phases will be shortened, and the reverse will happen in case of cold temperature. So why these kind of changes are happening here? Because if we increase the temperature, so there will be uh, increase in the metabolic activity because of increased enzymatic activity. We know that the Km value of enzyme, it depends upon the temperature. Okay, so within at a optimum temperature, so the Km value will be increased and the enzymatic and metabolic activity will be increased. Increase in temperature will also promote the activity of the ion channels, and it will also increase the conduction velocity of the nerves. And the third thing is that the viscosity of the muscle cytoplasm, it will be reduced. So this viscosity is actually a force that resists the contraction. So if the viscosity is reduced, if the conduction velocity is increased, if the enzymatic activity is increased, so it is obvious the contraction will be much more faster. That is the reason the latent phase, contraction phase and relaxation phase, the duration of all these phases will be shortened, will be decreased. And regarding the force of contraction or height of contraction, it will be much more increased. And the reverse effects you will see in case of cold environment. Now we want to know, in the experimental setup, what are the instruments we use. So this is the experimental setup. It almost look like the experimental setup of the simple muscle twitch curve, in which we took the simple muscle twitch curve. I think you remember it was the experimental setup. Here few instruments were related to the are the electrical appliances that are used to give the electrical stimulation to the nerve muscle preparation. We know that nerve muscle preparation, it is fixed on the myograph board with the stand, and with the help of this current source, primary key, Du Bois in Raymond induction coil and short circuit key and all these things, these are the electrical appliances which are related to the application of electrical stimulation to the nerve muscle preparation. In and we also had one recording instrument in this experimental setup, that is your kymograph with the drum. Now the same experimental setup almost it is followed, that is the primary circuit and the secondary circuit is everything is unchanged. The only thing that is changed in this experiment is that we have changed the myograph board into a specific chamber that is known as the Lucas chamber, because here we have to give or apply the warm and the cold ringer solution. Okay, and we need the nerve muscle preparation, we want it has to be dipped into this solution for 2 minutes, then we will see the effect of it. Okay, so in the myograph board we cannot store, or the myograph board cannot hold this warm or cold ringer solution. That is the reason we have replaced the myograph board with this Lucas chamber. Okay, and just like the simple muscle twitch curve experimental setup, we have the nerve muscle preparation, we have the Du Bois Raymond induction coil, simple key, short circuiting key, kymograph and the drum, and the tuning for time tracing. The extra instruments that we need in this setup is the Lucas chamber, cold ringer solution, warm ringer solution, and the thermometer. Okay, so these are the special things needed. Now one by one we want to see these instruments. The first one is the Lucas chamber, you can see here. So here actually the electrode is attached. You can see here in the first diagram, you can see the from the short circuiting key the wires are going and they are connected to the Lucas chamber at this portion where actually the electrodes are present. So the pair of electrodes we can see here. So we can see also there is a drainage tube with a pinch clip. So when the experiment is over, so we will drain it and pour warm linger solution. When the warm linger solution effect is seen, then we will drain it again and we will pour the cold linger solution. So we have this drainage tube and the pinch clip. We have the cork for the fixing the nerve muscle preparation, and this Lucas chamber is made up of perspex bath. Perspex is not a good in a conductor, so that's why we were using this perspex bath for making this Lucas chamber. We have the ball and socket and the pointer, writing lever. With the help of writing lever and the stylus or the pointer, by this we will take the record on the rotating drum. And obviously just like myograph board we have the stand here. So this is the Lucas chamber or muscle trough, we can say. Now we want to know what are the other things that is required in this setup. Obviously the nerve muscle preparation, and we know that it is the gastrocnemius muscle and the sciatic nerve. Then the thermometer is required. These are the electrical appliances: Du Bois Raymond induction coil, simple key, short circuiting key, and the kymograph with the drum. The special instruments that we need here, that is a thermometer and the warm ringer solution, the cold ringer solution, and the tuning fork, just like the SMT for the time tracing. It has a specific frequency, that is 100 cycles per second. Now how actually this experiment is done, we can see that initially we will dip the nerve muscle preparation at the ringer solution, which is at normal temperature. Okay, so we will immerse it for 1 to 2 minutes, and we will initially record the simple muscle twitch. So this is the simple muscle twitch. We can say, see here, it has been recorded. Now what we will do, we will drain the Lucas chamber, then we will again put the clip over there, and we will fill the Lucas chamber with Ringer solutions at 38 degrees centigrade. With the help of thermometer, we will ascertain that the temperature is 38 degrees centigrade. Now the temperature, we should wait for 2 minutes and keep the nerve muscle preparation within this warm solution for 2 minutes, and we will again record the SMT. So this is the effect we can see here when we have dipped or immersed the nerve muscle preparation on the warm Ringer solution. Then we will again drain it off and fill the Lucas chamber with the Ringer solution at 12 degrees centigrade. And we will note the temperature of the ringers with the thermometer in the Lucas chamber. Then we will wait for 2 minutes before recording another SMT on the same baseline, and we will keep the point of stimulus and strength of the stimulus same. This point is very important. We know that force or height of contraction, it depends upon the intensity of stimulation, it depends upon the frequency of stimulation, temperature, initial length of muscle fiber. So all the other variables should be kept constant. So we will keep the strength of stimulation same, we'll keep the point of stimulus at the same point, and we will take the reading. So here they are waiting for 2 minutes after immersing the nerve muscle preparation into the cold Ringer solution, and after that they will take the reading, and this is the reading. We can see the effect of low temperature on the muscle contraction. And last but not the least, after all completion of all these experiments, we need to take the time tracing with the help of this tuning fork of 100 hertz frequency. And we know that how can we calculate the duration? We know if 100 cycle is for 1 second, so 1 cycle will be 1 by 100, that is 0.01 second. So the distance between one crest to another crest, that is 1 cycle, is calculated as 0.01 second. Number of crest we will identify, and we'll just multiply with it with 0.01, and we will get the duration of all these phases. So some precautions we must take. The recording should always be taken on same baseline. Otherwise, we cannot compare the effect of on 3 different settings, that is in the normal temperature, at high temperature, at low temperature. If we don't keep the same baseline, then the duration of all these phases cannot be compared properly. Keep the point of stimulation unchanged and use the same strength of stimulation for the whole practical. And the temperature of Ringer solution should not exceed 42 degrees centigrade, and it should not be less than 5 degrees centigrade, because we know that if the temperature is more than 42 degrees centigrade, all these muscle proteins, they will be denatured, so the contraction will be improper. The effects of warm Ringer solution should be recorded before the effect of cold Ringer solution, since cold Ringer inhibit all enzymatic activities in the muscle, which may be difficult to revert. So this is the recording, and when all the process is over, we have to compare. So here we can see that the latent period of normal Ringer solution is AB1, and when we are applying the warm solution, it is AB2, and when we are giving cold saline, it is AB3. And when we have measured it, we have seen that AB2 is the least. The shortest duration will be AB2, as the contraction will start early if we increase the temperature. Similarly, BC1, B1C1, B2C2 and B3C3 are the contraction periods. Among them, B2C2, its duration is shortest, because temperature, if it is raised, the contraction will be early and short. And C1D1, C2D2 and C3D3 are the relaxation periods, and C2D2 is shorter, because if we increase temperature, there will be shortening of all these phases due to reduction in viscoelastic forces. There will due to increase in nerve conduction velocity, there will increase in metabolic activity or the enzymatic activity. Viscoelastic force, as it is reduced, it will also increase the height or force of contraction. That is very obvious from this curve. At 38.8 degrees 38 degrees centigrade, you can see that height of contraction is maximum, whereas when we have lowered the temperature, the reverse has happened. So this is in short the effect of temperature on the simple muscle twitch curve. Thank you.